Thanks everyone. This keynote is about like how event-driven application done right, and I get through it. What I mean with that, and just a brief intro. So my name is Matteo Merli. I'm the CTO in StreamNative. I'm one of the co-creator and of Apache Pulsar, and I'm also the PMC chair. I was one of the ex-co-founder of StreamNative. I was also in Splunk and Yahoo, where I was the tech lead for Pulsar there. Before going into the event streaming applications and everything, I will first go on the. I think you share some of the stats, but this is one of the stats that I like most, and so this is from ossinsight.io, and it's basically a chart of like the number of pull requests per different project. So and all these projects are in the streaming and messaging space, and you can see the Pulsar contribution really start in to ramp up in 2017 to 2018 after Pulsar was made a top level project, and then it really increased the speed and the velocity of this contribution during last year. So it's a very exciting moment in the community, because there is like a lot of contributors and a lot of ideas, a lot of new changes coming into Pulsar, and you can see that the velocity is ahead of any other projects in this space. So that's very exciting for us. Another way to look at this is so this is not metrics around the community, and this is the monthly active contributors. So this is basically the number of different people that are submitting code patches each month to this project. And even here you can see, so Pulsar is a green line in the chart, and you can see that is ahead of any other project in the space. So there are more contributors compared to Kafka and anything else. So it's I think it's a sign of a very healthy community. Is very active, and there are a lot of contributions, a lot of fixes, a lot of improvements coming in every month. And if you look at it from as a perspective from Apache Foundation, Pulsar is one of the top 5 projects in terms of contributors. We have the very active Slack community, number of commits, and also number of organizations that are using Pulsar in production and in the past few years. And this is just a tiny set of Pulsar users that have been publicly speaking around how they use Pulsar. So from the interesting part is that this adoption is really like global. There are like very big US companies like Intuit and Verizon, or Splunk and Yahoo. And at the same time, there are like very big companies in China, like Didi, Tencent, Baidu, and Huawei. I think is not here, but is also using Pulsar. So it's and across the board. So in Europe, in South America, in Yahoo Japan, and everywhere. So it's really exciting, and it is also like very exciting that it is really like cross industry. There are companies like e-commerce, marketing technology, or like telecom providers, or any kind of industry that there is a good fit for using Pulsar in different scenarios. And I'll try to introduce how the platform has evolved and what we mean by messaging and streaming. So the first the distinction here is that even though like we speak many times about messaging and streaming, sometimes these the meaning of these two words is getting confused, because many people use them for meaning different things. So I feel that a better way to distinguish is really like reasonable about use cases, and if you group the kind of use cases, you can identify 2 different domains. On one hand, we have the application domain, which typically is around online use cases where things like a payment service that has to accept payment requests and coordinate the payment, or things like inventory management, recommendations, or like tracking, alerting, like all the things that interact with the services and users. And on the other side, you have the data domain, which is more like, you can see that more as a data pipeline instead of an application. And the distinction can be blurred there, but it's a kind of. And but on this data pipeline, mostly you are getting data from some source, apply some processing logic there, and then outputting the result. So Pulsar supports both this model and both these classes of use cases. And I will concentrate more on the application domain at this point, which is where you have more of the complexity around all the interaction between these different services. And if you look at the evolution of the application domain, like in the past, basically most of the applications were built with the HTTP REST, which is basically an RPC model. So you have a request to a service, the service will reply back to you as a user, and it's simple enough, it's easy to implement, and it's easy to understand. And this model scales well, while the number of services, the ecosystem of these services is small, but so that you can target each service and get the RPC requests to these services. The problem is that this gets harder and harder as you grow your mesh of services. So if you start having more services, these services will start having dependency between each other. So they will say you call service A, but service A is depending on service B and C. And so one request here will span to multiple requests, and you get this really complicated topology of services. And it's where sometimes it's very difficult to understand who depends on what. And as you grow this topology of services, the thing that happens is that you are coupling these services more and more. So you keep coupling these services, and it gets more intertwined all between each other. And the problem is that in this, once you have these mesh, these interconnected services, one service is failing, it is causing issues on entire network of services. So now the service can fail and now propagate these failures back on the calling services and eventually on the user, or the services can just be slow. It might be up and running, but replying more slowly. And the problem with this is that the fallout is larger across the entire network of services. And essentially, like, everyone is going to feel the pain. Eventually, it will cause cascading failures across the board, and that's a very dangerous situation to be in. Once the company scales up and you keep adding services, then you want to be asynchronous. That you want to be that these services are asynchronous to each other, to avoid having resources tied, like a thread waiting for a response. And the way that you can get this asynchronity is to decouple the services and the user from the services and the services between themselves. And that kind of like has driven the evolution that most company has been evolving through the past few years towards event-driven architecture. So now you get basically each one of the services are interconnecting through a messaging and streaming platform. And if you look at the kind of technologies in this space, there's been a large number of them, starting from the JMS APIs through Kafka, and but also like with things like RabbitMQ, ActiveMQ, Solace, TIBCO, and also the AWS services like Kinesis and SQS and so on. Like all of these have been existed, and I would try to get a bit more of what are the semantics that are really needed when you are designing an event-driven application. And to give really a quick example on what a complex modern event-driven application can look like. So so this is like purely an abstract example, right? But if you think of an e-commerce application, and an e-commerce application will have some front-end service, and that receives HTTP requests from users. And some of these requests could be a request to make an order. So the service can make that request effective by publishing a message on a topic. So you could have, for example, here an order request topic. And now you will have a backend service that is processing these order requests. And it might also want to keep some status of on the order. So the order could be in fulfillment, it could be in shipping status, or like any other kind of business status here. The interesting part here is that you can use very different semantics here to build these services and to interconnect them. For example, like the backend service could use a queue consumer because you don't have any ordering requirements across different orders. And so you pick one order, you process it, and then you publish your status into another topic. And you might want to do that using a transaction so that the effect of this operation is exactly once, and you don't have duplicates or losses. At the same time, this backend service might keep a table view, which is I'll explain a bit more, but is a key value view of your topic. And in the same way, the front-end service might want to keep a table view on this, so that it can serve to the users the latest status of each service, for example. And finally, on the right side, we have an analytics service. So this is like a big black box, but you might want to see that as a streaming consumer. So you have a reader, which is a streaming consumer, and is taking all these orders and analyzing them. So this is just to illustrate that when building a complex system, you need very kind of different APIs and very different semantics to build this complex application. And but this semantic it's a complex application, but it's easy to build, as in that you have all the right semantics out of the box in Pulsar, and it is very easy to build a very scalable application because every component, it is decoupled from the others, and you can scale them independently. You can know exactly how fast each stage is compared to the incoming data and so on. So it immediately gives you the visibility on what is happening throughout your system, as you can observe these messages and the rate and the lag of each service compared to the previous stage. So the questions here is to support this kind of applications, what is the right data abstraction, and also what is the right API? Is it a streams? Is topic? What is a hues? What is that API? And what are the primitives that you want to provide the users? And what are the processing semantics that have to meet the business needs? And finally, what are the tooling around the solution? So starting from the kind of like the 5 fundamentals of the modern event-driven applications. And you can translate these into topic streams, shares versus exclusive, and processing semantic and layers of abstractions. So I'll start with the topic first. And so this is going back a bit on a textbook definition on what's topics, what is PubSub, right? So PubSub has been a concept that has been around for like 30, 40 years, I guess. If you look at the textbook definition of PubSub, is really that you have asynchronous broadcast of messages to a set of consumers. And the main purpose of PubSub model, the PubSub pattern is to decouple producer from consumer, so that if you are a producer, you don't have to worry about where your consumers are, who your consumers are, where they are, and whether they up and running or not. You just basically decouple yourself from the consumer. So your availability is given only by the messaging bus. So if you can write on the message bus, then you're good to go, irrespective of whether the consumers will be are up and running, consumers are consuming, or they're having issues or not. So this is the first fundamental property. The coupling and will give you the availability. And the availability of the producer is only determined by the messaging service, not by the 10 or 50 services that are downstream. Another fundamental property here is that the subscriber state is managed by the system. So this is important in the PubSub model, as in that it allows to each consumer to know where they're consuming from. And this is like very different from what Kafka provides. So there's not really like PubSub in that case, because of Kafka, the offset is always managed by the consumer, and it can be stored in the server, but the server will not determine what message you have to delete based on that subscription state. And you can also think of topic as replayable streams. If you extended that definition, now you can have like infinite retention of data, and now you can think of your topic as a source of truth of all the events that happens in your business, and so it's a source of truth that you can read and from any position. So you can roll it back and read from any position that you want. And you can also think of different ways on how the event can be stored. A common format would be by row, so that you can is a log of events, and you can position yourself in each position in the log. Another way to see the same data would be a columnar format, and the two are not exclusive. So if you think about like a lakehouse, and if you integrate the lakehouse model into the messaging bus, now you can see your data in both ways. You can see that as a stream of events, but also as a sequence of segments and each segment is stored in columnar formats. And now you can use all the lakehouse tooling and the lakehouse integrations to read the same data. It's kind of like having a dual view over the same data that you have in the topic. And going from the pure topics and the storage abstraction, now we can go a bit higher. So you can still think of your topic as a stream, which again is an unbound sequence of events. Now it's ordered, replayable, and partitioned for scalability. But you can also see as of your data as a queue. And again, the queue is like, even before PubSub, a queue is an even more fundamental concept in computer science. And it is the fundamental decoupling mechanism. You have queues everywhere in every system. So every system design, every system component will have queues in many different places. And the queue is the coupling. Queue is buffering. Queue is also a way to distribute work across a set of workers. Even if you think of an in-process queue, you typically have multiple producers and multiple consumers on the same queue. And typical strategies there around the routing around the round robin, so that I want to get the message to the first available consumer, or I want to have some ordering. So I want to have per key ordering. Another fundamental idea around the queues is around tracking individual messages. So the moment you have multiple consumers, now you have to basically track each and every message. And the queue can be either destructive or non-destructive, as in that when you pull the message, you can either acknowledge or pull it back. And finally, a common patterns around using queues is also around the delay. In many cases, it is very useful for application to think that I can put the message in the queue and have it delivered sometime later in the future. It can be minutes, it can be seconds, minutes, or hours or days, as an example. And if you're looking at another way to see the data in the topic is you can think of your topic also as a table. So the topic is a sequence of events, but if you put all of them in a table, basically you can have access to the latest value per each key. So each message has a key, and you can basically have a projection of your is really a view. So we call it a table view, for example, in Pulsar. And a table view can be very powerful because it can be used to share state between the different processes. So you can use that as a way to that I coordinate multiple components, multiple processes. And you can also be used as a distributed cache with local reads. And you have different ways to implement caches, but you want to push all the updates to where they are needed. And that's kind of like a way that each time you want to look up something in the cache, you don't have to call a service, like you don't have to go to Redis and ask what is the latest value in the cache, but you have it locally in your process. And another important part is that this table view is integrated with transactions. So if you have transaction use case, that you will be able to use the table view in a very natural way there and see only fully committed data. Having talked about topics, queues, tables, like all the ways that you can think and reason about the data that you publish, all the events, I'm going to go about the shared versus exclusive. So here there is a bit of duality between the producer side and consumer side. So you can have share producers and share subscribers, or share exclusive and exclusive, or share and exclusive. The setting an exclusive producer is a way to manage producer epochs, and that's important because it's kind of like exposes the you can build a very powerful distributed system on top of Pulsar. We can like exposing like this building block semantic to build these distributed systems. By having exclusive producer, you can implement things like leader election without needing any additional service. So, for example, you might want to have many instances of your service, and you need to have one of these instances to be the leader. So if the producer that can acquire exclusive access, it can make the decision and enforce them and communicate them to everyone else by publishing on this topic. And as long as it can publish on that topic, the decision is final and applied by everyone. On the other side, on the consumption side, we have different ways of consuming. So you can either have shared subscription where you want to distribute the work across multiple producers, or you might want to have exclusive access if you want to receive each and every message in the same exact order as they were published. So different ways on each side on how do you want to give access to producer and consumer. And regarding the processing semantics, so Pulsar has, by default, is at least once. Most people are familiar with this. Messages can be pulled multiple times. So if there are failures, the duplicates are possible, but no missing data. You might have some duplicates only. We also support at most once with no persistent topics, in which case you can miss data. And also exactly once, and where the data might be pulled multiple times, but the processing is only done once. And So you have no duplicates and no missing data. And this is achieved through the Pulsar transactions we were introduced in PIP 30, and they're like GA in Pulsar 2.9. And to close this presentation, I will go on the different layers of abstraction that are useful for application developers to think, and where it makes sense to use different layers depending on the scope that they're trying to achieve. So at the bottom level, we have the client library. So the client library in Pulsar is something that is simple, high performance, and is language agnostic. There is a custom protocol that is based on, it's a TCP protocol based on protobuf. And the protocol is version and maintains backward compatibility with all the versions. So we are really making sure that once you have a client library, even if it's very old, you will always work with against Pulsar. And we support many different languages from Java, Go, Rust, C#, C++, Node.js, Python, and Scala. So there are multiple ways of interacting with Pulsar. And so this is kind of like at the lowest level. So it's very flexible. You have to basically programmatically use this API to publish and consume data from Pulsar. The one level up, you can think about the REST API. So there were already the admin API, so you can interact with the REST either through, Pulsar admins is a CLI tool, but making admin requests to Pulsar. But there is also that since PIP 64, a REST API to publish and consuming data. So this is something that is coming in Pulsar 2.12, and we'll be adding the full capability to publish and consume data through REST, and making sure that even if you have like a tiny script, you don't need any extra dependencies, but you can publish and consume data. And finally, going one level up, Pulsar has functions. So functions are serverless event processing. A function can be seen as you submit a piece of code, and this code will be getting events from a number of topics, apply the logic that you have provided, and output the result on a different topic. And the logic is really free-form. So you can just do like a basic transformation, or you can call external services to do enrichment and everything in between. One of the most powerful things of function is that it is fully managed by the system. So you submit your function code, and that is running on the server. You don't have to monitor that. You don't have to operate anything. So it's really like an out of the box supported. And for functions, we support Java, Go, and Python. And another very powerful thing is that there is really like no SDK even needed. You can just submit a Java function or a Python functions, and you don't have to program against any API there. So you can see functions as a way to go one level up from the Pulsar client. So function internally will use Pulsar client, but they're much more easier to use than Pulsar client, because they're abstracting everything. So you don't reason as in that I need to create a consumer, I need to create a producer. What are the options on these? How should I use? How should I act? And so on. So as you're going up the layer of abstraction, you have less complexity, and but also less flexibility. So Pulsar functions are easier to use than regular Pulsar consumers, but they're also less flexible because they are opinionated. So if you need more flexibility, you should just use the Pulsar client directly. The question there is that really that we have seen that in many cases, these going up the layer and providing easier way for developers to write that logic is very important. So one way that we okay, functions are easy to use, but there is still code involved. There is still a lot of things to understand when writing a function. So what can we provide for the developer to make more use of the data they have already in the topics? And the answer there is that we have been thinking around is around SQL. So instead of writing a function, you should be able to just provide some SQL query, and that SQL query should be able to get applied on the topic and provide you the basic ETL transformations, projections, basic analytics. So we are introducing PF SQL. We use Pulsar Functions SQL as a way to achieve that. And essentially, it is a SQL language, and in a way that you can provide SQL queries, and it is designed for Pulsar Functions. And the intended usages here are around filtering, transformation, and routing, and but also transformation for Pulsar IO connectors. So if you have a connector, you can basically pre-apply transformation before it gets sent to a sink, or post-apply. Pre-apply as well. When you receive events from a source, you can apply the transformation logic before it gets published on the Pulsar topic. So if you look at this syntax, the key part is that you can read every query without knowing anything, and you should be able to understand what this is about. So if you look at the first example, the filtering is saying, okay, insert into this output topic and select star from input topic, where key equal, say, either MTV or key equal SF. So basically, you provide filtering on the topic data based on the message key. Now, this filtering can be applied on using the message properties or the message key or individual fields. So, for example, like if you look at the second example, is a transformation. So it would be doing a select star from input, and but you can do also select individual fields, columns of that table of that message. So when you do select foo and bar from input, you are basically transforming your input message. Essentially, you can drop the column, for example, or you can apply a function and that column. So for example, you can like redact sensitive data like SSN numbers or like date of birth or any data that you want to drop. So, and with that, you can provide filter views and transformed views that you can provide to different people with different level of access to this data. And finally, I mean, the most complicated one is a routing, but it's kind of like intuitive to read. So you have insert multi, and so if the key is SFO, then you go on topic one. If the key is NYC, then you go on topic two, and so on. So basically, you're routing the message based on the properties on the key or the fields, and then you may have that. Okay, if nothing applies, then you go on topic four, and on top of that, you can also provide the transformation and the filtering. So you can stack all these three layers together, and it becomes very kind of like a Swiss knife to have all this routing transformation for Pulsar. So I hope that gave a good overview of all these different ways that you can see your event-driven applications, and to just have like a quick conclusion here is that complex event-driven applications require a wide range of abstractions, APIs, and semantics, and for each different problems. And there are multiple different problems that you have to solve to support them. But Pulsar is the only system that solves all these problems in the most natural and comprehensive way. So you don't have to use multiple services, multiple systems to solve all these problems. You can just use one, and that is good for across the board. And with that, I will just leave the word again to Shadow. Thank you.
Okay, thank you, Matteo. Thank you. Okay, so does anybody have any questions?